Okay, another minute or so here and we'll get going, waiting for a few more folks to come in. Thank you guys all for joining me here today. This talk is deployment automation from developers' keyboards to user screens, so hopefully you're in the session that you were looking for. Obviously lots of really cool, exciting sessions this week here at reInvent. So come on in, folks. There's lots of seats, bunch up front. Don't need to sit all the way in the back. I'm not going to call on you to ask any questions, so make yourself friendly, scoot in, and make room for some other people here. And cool, doors are shut, so we'll get going. So again, thank you for coming to the session. I really do appreciate it. My name's Chris Munns. I'm a solutions architect for Amazon Web Services based in our New York City office. I've been with AWS for a little over 3 years now, working with customers of all different shapes and sizes. Previously coming from an operations background, working for a number of startups in New York City and then some other places before that. But deployment automation and automation in general is a topic that I spend a lot of time on and that I care a whole lot about. So I'd like to get a sense of folks who are in the room here. How many of you feel that you do a really good job of automating your deployment process, again, from developers all the way to production today? Okay, some good hands. How many of you feel that there's an opportunity for improving or iterating on your process today? Cool, awesome. So hopefully, again, it's a really big topic. It's a really wide topic. There's lots of intricacies to it. I wish I could just say, here's the pattern and here's how you go. But we're going to cover a lot of different high-level topics today, as well as kind of getting into the nitty-gritty of some things. This week at reInvent's actually been really exciting in this space, right? Both yesterday and today, a whole lot of different things that you've heard about us releasing here at AWS, from code deploy to Lambda today, and a lot of things in between. So I'm going to be talking about some of those things, but this is not a session that will be diving too deep in any one of those. So unfortunately, if you're looking for that, my apologies. So deployment automation, why is it kind of a big deal? And typically it's kind of a big deal because historically, people didn't automate this process. There wasn't deployment automation. Manually, people were determining what release cycles were. They were performing QA testing manually. They were performing testing and staging manually. They were moving that code from whatever sort of, hopefully, source code repository from one layer to the next layer to the next layer. They were then testing things and monitoring things manually, and then when there were bugs, it was a manual process to document them, report them, and then kind of rinse and repeat this whole process. And so why is it? Why was it that typically deployment automation has not been a very big focus in the IT industry for a long time up until more recently? And a lot of it comes down to concerns about risk of change. Right, it used to be that development was such a big risky thing when people were shipping software in boxes into stores and over the mail and things like that. But in a web-centric and even like a mobile application-centric world like we're seeing today, those risks and that risk concern changes greatly. Cost of development time has definitely dropped given kind of the frameworks that we see nowadays that are out there, SDKs, varying different quickly prototyping type languages that exist. So again, change is there. Infrastructure needs and costs used to be a bigger problem, right? If you were developing a new application, the next version, it needed more hardware, more database resources, what have you. That was, historically pretty much a bottleneck for a lot of moving forward of development practices. Then you had things like disconnects between business groups, between product, between dev, between operations, between other things. That's why we see kind of this whole DevOps movement that's grown over the last couple of years. Impacting everyone from enterprises to small startups and everything kind of in between. And then lastly, you kind of also had people, people were also used to really long release cycles, right? So if you look at typical boxed software that you install on a server or on a laptop somewhere, that's stuff that comes out yearly. Nowadays, you don't have web companies and app companies that are doing yearly releases, right? You have very, very smart startups that are doing releases multiple times a day. And then again, lastly here, 2 points, right? Either previously people had too much process involved in deploying and building applications, and so you'd fall into kind of analysis paralysis, or you had too little process, and everything was just kind of scattershot, and so there wasn't enough structure to get things done in an efficient way. So again, cloud computing solves a bunch of these concerns, at least in terms of agility, cost of resources, the ability to quickly test things and iterate upon them. So that's a good thing. So that does get rid of a whole bunch of the concerns that people had with development today. But what you still have is kind of the action in the middle here of what needs to happen in order to get the code from our developers to our end users in a quick process, in a reliable process, in a repeatable process that, again, like some of the cutting edge startups that we see today, are doing tens of times in a day. And also, we're not really just talking about usually just shipping that code directly to that end person. We're talking about its life cycle and movement through various environments inside of our infrastructure. You might have some number of these today. Hopefully you're not deploying just straight to prod. But QA, staging, development, different tiers inside of that, tiers of this for each of the applications that you might have. When you talk about things like microservices and service-oriented architecture, this diagram could have hundreds of these boxes on them at a really large organization. And so we have to ask ourselves a number of questions, right? When do we move our code through each of these different environments, right? What is it that triggers this? When does it happen? What is it that's kicking off testing in these steps, right? Hopefully you're doing some level of code testing inside of your infrastructure. That's an important part of automation and being able to move quickly. What is the actual thing that is moving this code, right? Hopefully we're not FTPing code back and forth between servers these days, and we're going to talk about some options for making this a simpler process. And then lastly, and very importantly, who's being affected by these changes, right? When we talk about startups and other organizations that are deploying tens of times a day across development teams that could be in the many dozens, if not over 100, where people are continually pushing to these environments, right? How are they impacting the rest of the team? How are they impacting everyone else around them? So we go back and look at this question mark here and think about what has to fill this gap. I see it kind of lumped into two different categories. First one is developer tools, so tools that are actually going to be benefiting and working with our developers, or at least our developers will work with those in helping them with this process. And then actual best practices and patterns for using these tools and other tools. A lot of times people don't think about the actual best practices and patterns that exist here. They just focus on the tools themselves. But these different tools that we're going to talk about today, there's definitely right ways to use them, wrong ways to use them, and better ways to use them. And then kind of combining the two of these is what's going to help us get our code, again, from our developers to our end users, and hopefully done well. So where do we begin with all of this? Again, lots of different components, two different categories we're going to look at, and what I always like to say is that you want to think about, in this case, the end customer that we're concerned with. In this case, the end customer that we're concerned with is the developer. So whether you are part of an operations team, a DevOps team, a dev tools team, an infrastructure tools team, a core team, or whatever you want to call it, if your end customer is the developer, you want to try to put yourself into their shoes and understand the process that they're looking for and what works best for them. And we want to give them a number of things. We want to have them have frictionless access to the infrastructure, right? This is one of the big key things today that comes into the DevOps mentality. We want to have them be able to move fast on our company's product mission and goals via being able to rapidly do development and deployment of that code. But we also don't want them to have to know every single aspect of what's going on inside of our infrastructure. A great story, actually, an example of this. I meet with a lot of startups, both on the East Coast and the West Coast. I was meeting with a very small young startup, just started out, was in an incubator, and one of the lead developers and founders had come out of a very large AWS customer. And he was talking to me and he said, when I was at that company, we had this great thing that allowed us to scale up and down our servers horizontally very easily. And I was like, do you mean auto-scaling? He was like, yeah, we called it auto-scaling. And I was like, no, auto-scaling is something that's part of AWS. And he had no idea. And the reason is because this company had done such an amazing job of building tools for the developers. The developers never needed to understand what the underlying AWS services were. And if it's something that's not core to their ability to get their job done, then that's fantastic, right? You're not making them have to learn something that isn't really in the path of what they need to do every day. And then again, we want them to not have to experience any pain when it comes to getting their code where it needs to go, right? Remove that friction, make it easy, make it not too complicated. So what are the things that our developers need? Primary one that I like to focus on the most, something that I think a lot of companies don't spend enough time on, is making sure that they have environments that are as similar to each other as possible. We want these environments to almost look exactly the same. They could be maybe slightly different sizes, very slightly different configuration, but we want them to look and feel almost identical as far as the developer's perspective is if they are viewing one of these and then viewing the other. The other, as I was mentioning before, is we want the process to be incredibly simple, right? Put a button on a web page that the developer clicks and stuff happens and they don't have to do anything else. Make it so easy that almost anyone in the organization could do the process. I know of a very large web company in New York City where the company lawyer has the ability to deploy code to the website. You're asking yourself, does the lawyer write code? No, he doesn't. But he writes their user license agreement, and when he has to make updates to it, they gave him the ability to push that out live himself, right? He knows he needs to edit a file. They taught him how to commit to Git. They taught him how to push it through the development process, a bunch of simple web page GUIs. And again, you have someone who has very, very low technical knowledge, capable of deploying code, essentially. And then again, you don't necessarily need to chase complexity out of the process, right? This is a complex thing that we're talking about. There's going to be complexity. But we don't have to have everyone in the organization have to know how the sausage is made. We just want to give them the sausage on a plate, have them enjoy it, and continue on with their day. That said, though, we still want to make sure that they understand the results of their actions. If developers are deploying code from one environment to another into production, and they have no way of seeing or visualizing the results of what that code change is doing, then we're really flying blind out there when we're making these changes rapidly. So let's dive into some of the developer tools that you're going to want to give access to your developers such that hopefully it will help make their life easier in this process. And when we talk about them, again, this is another thing that we can categorize, right? So development infrastructure, very important. CI testing tools, deployment tools, actually, and then monitoring metrics and logging. The last one, again, is super, super important one. When we talk about development infrastructure, again, going back to the picture of those adorable little puppies next to each other, we want this to look and feel just like the production puppy when it's the developer puppy on someone's development laptop, whether it be a Mac or a PC or what have you. And so there's lots of different options for this. So there's local VMs, right? You can use varying different versions of virtualization technology for this today. You could give them EC2 instances. Many companies do this. There's definitely a lot of techniques for doing this intelligently and effectively in a cost-effective way. There's tools like Docker. We heard a lot of exciting, awesome things about Docker today. Very, very popular technology. I haven't really seen anything in my career in the IT industry grow as wildly quickly as Docker's been growing lately. And then lastly, a really important tool that we're going to talk about, which is Vagrant, which is more of a management tool that sits on top of a lot of these different technologies. So Docker, unfortunately, I'm not going to have a chance to go too much into the EC2 container service today. The service team was super secretive about what they were working on to the point where I actually didn't get a chance to write slide content about it before the content was due to the marketing folks. So hopefully you got to see some of the sessions about that. But the big picture around Docker, as was being talked about today, is the idea of this container, this portable object that you should be able to pick up and run in any environment that you have exactly the same, with the same results. Right? This is, again, going back to the picture of the puppies, and imagine each one of those is a place where you can run Docker, and Docker should behave the same for each of them. And it's a very atomic way of deploying resources, deploying assets, libraries, packages that have to deal with your application and your code in such a way that you don't have to worry about version drift, you don't have to worry about incompatibilities. Ideally, if you're doing it right, things should just work. That said, it's still a very new and rapidly changing technology. I think Werner kind of acknowledged that on the stage today. But again, you can take a look at container service and play with that and understand it a little bit bigger. A peer of mine, Nate Slater, actually wrote a really great blog post on doing dev and test using Docker. You can find it on our Medium blog, which I put a bit.ly link in. If you can't remember, quickly write down that top link right there. Let people take pictures of that real quick. Great. So the next tool up is one that I've been a huge fan of also for a long time now, or at least a long time in terms of since it's come out, and that's Vagrant. Vagrant is, you think of it kind of more of a management wrapper tool around a number of different virtualization technologies, whether they be VirtualBox, VMware, EC2 images, Docker containers as well. And essentially what you can do is use this to manage environments on-site of a developer instance. In this case, what you're seeing here in the example down below is I installed Vagrant in VirtualBox, which is a hypervisor technology that works in OS X. And then in just a couple of commands here, I was able to go pull down a CentOS 6.5 image from a centralized site that stores Vagrant images. They call them boxes. And then in a matter of 2 commands, I'm able to start up this virtual machine on my laptop. So you can imagine in an environment where I have a large group of developers, I want them all to be on the same environment. I find a place where I can store this box in Vagrant and refer to all of them and allow them to very quickly and rapidly fire up the exact same development environment. And you can layer other configuration management tools on top of this thing. Again, you can see as I log in here, it's just a raw Linux instance that's running for me. But this is a great way to allow your developers to do local development, whether they're in the office, at home, on a plane, sitting on a beach, whatever they might be where they need to do development work, give them this standardized environment where they can work with your tools and work with your code and everything else. Moving on here, before we get to the next section of tools, I think it's really important to define two terms that people very loosely throw around these days. The first being continuous integration, right, which is essentially techniques and tools to implement a continuous process of doing quality control on your code. That quality control could be looking for bugs, or even doing more complicated things such as validating security of your code, validating the performance of your code, etc. The next one, which is a continuous deployment, which is the act of taking the code after usually it's gone through a continuous integration environment and deploying it immediately out to an environment. So taking that code, shipping it out somewhere onto a server immediately. And so the two of these, oh, on the wrong slide? Sorry. Continuous deployment, again, pushing that code out very, very rapidly and making it available for you. And it's important to note something about these. Continuous deployment almost always implies continuous integration. You really can't do continuous deployment unless you are continually testing your code every single time that it's getting committed to your repository before it's being deployed out. That said, continuous integration doesn't have to mean continuous deployment. And I see a lot of people holding off on the idea of continuous integration because they're concerned that it implies that code is going to automatically end up on an environment, right? There's nothing wrong with putting a human wall between some of these deployment steps, right? A code review, a coworker sign off, whatever it might be, as long as code is passing tests, then it could be a manual action to push that code out somewhere. So I think it's really important to separate these two and understand how they impact and matter with one another. In terms of continuous integration and testing tools, there's a really wide ecosystem of these. The various logos that you see listed here on the slide are actually partners that we have. Many of them this week announced integration with code deploy, which we'll talk about a little bit later. Some of these are SaaS options, things like Jenkins and Bamboo you'd be installing yourself on your own infrastructure. But again, really awesome, powerful tools for doing continuous integration. Just an example of this, earlier this week, I led a bootcamp that dealt with using Chef for configuration management. And I talked a lot about validation inside of Chef. And I like to practice what I preach. So in this case, I made use of Travis CI's open source testing that you can do for open source repositories. I had to add 3 files to my code repo. Those 3 files were basically less than 20 lines total. Very straightforward. And every time that I commit code up to GitHub, it hits off a hook to Travis CI, which then will go and test my code. In this case, I was making use of Food Critic, which is kind of a linting syntax checking tool for Chef. But this is a really basic, powerful thing, right? This is actually my application code. This is my infrastructure code. And essentially, if you're dealing with any kind of code, infrastructure code, application code, passing these things through some sort of continuous integration environment is a must these days. So once we've gone through our integration code testing and hopefully the light is green and things are good, we can move forward. Now I want to talk about actually taking that code and deploying it. So here at AWS, we have a number of services that can help you out with this. One right here in the middle that we just announced this week, which is AWS Code Deploy, based very much on the Apollo tool that we have internally at Amazon. I don't have enough time, unfortunately, today to go into each of these, but understand that Code Deploy wasn't meant to be a replacement for either of these. All of these could have a place inside your larger infrastructure. In fact, today, CloudFormation can be used to provision Elastic Beanstalk and Elastic OpsWorks environments. So again, lots of different ways that you can cut and utilize these tools and use them inside of your infrastructure. And check out Code Deploy. It's a really, really awesome service that we have. And essentially what we're talking about here is tools that you can use to take your code and push that back out through your infrastructure. And one thing about this that's really important when we talk about environments and commonality and having them be the same is that it's really nearly impossible to do this if you're building your infrastructure by hand, right? All the tools on the previous slide help you build out your infrastructure. The same thing goes, though, once you actually have it up and running. So I'm a huge fan of host-based configuration management tools, tools like Chef and Puppet, Ansible, SaltStack, CF Engine. If you're not using one of these tools or one of their close relatives that exist out there, I think you're really missing out on making your life easy. So pick one of these tools. I'm actually not in a place to tell you which one is better than the rest. I think they all have a lot of common capabilities. But pick one, standardize on it, and use it everywhere throughout your infrastructure. So now let's talk about actually different methods that we could use to take our code and put it onto an end system. So we've got a couple of different options here. Shipping raw code, package bundling or building, containers, and then actually using AMIs to deploy our code out. Now, there's a number of deciding factors that are going to weigh in on which one of these different methods for deploying that we're going to use. Things such as the frequency, right? How often are we looking to do code deployments? Is it every potentially 10 minutes? Is it every hour? Is it once a day, once a week? The deployment size, right? How big is this application that you're shipping? If you're looking to ship a very large code repository, related assets, whatever it might be, deploying every 10 minutes may not be possible. And you might also want to look at an easy way to do that as opposed to, say, like just grabbing code directly out of a repository. The ability to handle failures, right? Are you going to roll back? Are you going to roll forward? Depending on these technologies, you might be locked into one of those options or another. The ability to have zero downtime deployments versus potentially some light downtime in your deployments. How do you handle that? And then lastly, complexity, right? Obviously a factor in doing this process. So we'll start kind of at the lowest common denominator, the simplest option that you have out there, which is just shipping raw code. All right, this is telling your infrastructure, whatever, your web servers, your application servers, hey, grab this code out of a repository, maybe you're rsynching it over, however it might be. Very easy to get started with. No need for some sort of mid-processing step of that code. You could take it right from your continuous integration system, potentially pass it out to a layer or make it something simple to put a button on. Some cons here, right? Rollbacks could be a challenge if you're replacing code in place. Let's say you're doing something like an rsync. It can be difficult to then go back and un-rsync that data. So something you have to think about. And it's also potentially harder to do at large scale. I was working with a customer of ours. They were growing very, very quickly, very, very rapidly. They had a very large code repository. And they actually found that when they needed to sync data from their code repository onto their fleet of web instances, they had so many requesting it that they would overwhelm that code repository server and put kind of an artificially large delay on the ability for them to get deploys out. So again, you want to kind of think about where that code is coming from and where it's going and how that impacts things. A number of AWS services actually make it really easy to do this model. Code Deploy, which we just launched this week, again, you can take data, or you take your code right out of GitHub and shove it right out into instances that are running the Code Deploy agent. Elastic Beanstalk and OpsWorks also allow you to take things directly out of a Git repository. And so it's really, really straightforward to use this model. If we take an example of shipping raw code, in this case with OpsWorks, what happens behind the scenes when I make a deploy. In this case, I'm actually bundling this up to a zip file and shipping it out. What OpsWorks does for me is it creates another directory on a system with a UID essentially of this deployment, and then it uses just a symlink to point to that most recent directory. So it's got a very, very small potential for downtime, depending on the language that you're using and what the interpreter of that language is, what your web server is, and so forth. It could potentially be more impactful, but again, very, very straightforward way to get your code out to an instance. The next option is package building. This is the idea of taking your raw code, putting it into some sort of a package, then shipping that package. This is kind of the next step up from just shipping raw code, essentially. What's great about this is it can be very atomic if you do it right. If you're using, down below here, things like RPMs or Debian files or MSI packages, very easy to version control those and version them and make those versions easily to replace. And then again, makes it very easy to track those changes across your environment. Right, if you're installing an RPM and you're bumping the version every time you deploy new code, it's very easy to query all the hosts in your infrastructure and say what version of this RPM is existing on these hosts. However, though, you could potentially have very large deployable assets. It's very difficult to do just a code diff push via something like a package. Right? You're typically packaging up the entire application and shifting it. So if you've just changed a couple of lines in one file, you're going to be shipping all of your files all of the time. So that's, again, where you have to worry about the impact of how long does it take to shift that data from wherever it's being stored to where it's going. Lots of different formats, again, for this, from the very basic, tarballs, zip files, bzip files, whatever you might have, to higher level packages like RPMs, Debian files, jar files if you're in the Java world, MSI files if you're in the Windows world, or potentially something else that might be based on your language of choice. There's a really great tool out there if you do go the package building way called FPM. It's a fun acronym and essentially written by a very awesome person who contributes to open source, wrote Logstash and other stuff out of frustration for dealing with various different package bundling formats that are out there. So really easy to get started with, and my apologies for those in the back who may not be able to read this. Essentially, I have 3 commands here. One is to install FPM. It's a gem today. Then pull in my code repo, and then one command to build an RPM. One command. Really, really simple, really, really easy to get started with, and then I could take this RPM and ship it out wherever I need to. AMI building is kind of the next thing that we have here, right? This is a bit higher up the ladder. This is building a new AMI for every version of your code that you're looking to deploy, and then using that AMI to stand up your application. It's basically the most atomic way ever that you could do this, right? There's no way to mix up versions when you have a whole machine that is representational of the code that you're looking to deploy. And again, it won't affect any of your running infrastructure when you deploy new infrastructure, hopefully. And so you could do things like put them side by side and do A/B testing and swap over versions and things like that. Again, in terms of cons, there's a lot more work that's involved here. Right? You're actually building a machine image, standing up new instances, redirecting traffic. It becomes a much more multi-step process in doing this. And you really have to think about things like data persistence. Right? There's absolutely no way to do AMI building as a deployment method if you are storing state on the server that you're going to be replacing. You're going to lose data, you're going to have a bad time. So you have to think again about that session state somewhere else. And then again, you have to think about how rollbacks would happen, right? How much infrastructure might you be running in parallel in order to enable an easy rollback? So a number of different tools to help you with this. Obviously, the AWS CLI and APIs can help you make this happen very easily. There are tools like Packer, which we'll talk about in a second. And then Netflix has an open source tool called AMInator, which also helps make this really easy and that you can very easily throw into your kind of whole deployment pipeline. Packer, really awesome tool from the same people that make Vagrant and a number of other open source tools that are out there. I'm not showing in this case in these two bits of text here how you install it, but it's a pretty simple to install package. And essentially you create a JSON file, which you see here on your right, which is basically defining the AMI that I want to build, what it's going to be based on, how it's going to be lightly configured. And then it's a single command to build that AMI. Right, so if you have a standardized version of this config, or you can automate the generation of it, you run this command and it builds the instance for you. Took a matter of minutes, I think, just 1 or 2 minutes actually to build the AMI that I have down here, and then at the bottom of it, there's the result of it. They can apply tags to it. They can do all sorts of good stuff like pass in user data. Really, really cool, easy, awesome tool, again, for rapidly creating AMIs if you do go that method. So once you've kind of got the idea of how you're going to push out and deploy your code, there's, again, still other developer tools that we have to worry about. This one, very near and dear to my heart, is having proper metrics and monitoring in place for your developers when they deploy this code. So metrics such as host level metrics, service level metrics, log analysis, build metrics, right? These are all things that we have to make readily available to our developers so that they can, again, iterate quickly, move fast, and have an understanding of what's going on in our infrastructure. Real quick, obviously, we want to talk about the AWS Marketplace, a great place to actually find these tools that I've been talking about, like the CI tools and many others. You'll find a lot of the companies that are down in the Expo Hall are marketplace partners of ours. And so it makes it very easy to find a lot of these tools and then implement them in your infrastructure. So if you haven't spent time digging around in the marketplace, you really should. It's amazing all the different stuff that's there from many different companies. So we've covered development tools. Now we're going to talk about kind of best practices and patterns. And so, you've picked a deployment method, right? Code shipping, AMI building, package bundling. How are we now going to go about acting upon it, right? How are we going to put that in motion? And so, again, we have a couple of different options here for how we can do this. We can do in-place deployments on our existing infrastructure. We can do rolling deployments across our existing infrastructure. Or we could do something like red-black deploys or green-blue, whatever two colors you want to pick and put next to each other, you can call it that. And I've seen it called both things, and I actually have called it both things myself before. And then there are obviously a number of gotchas, right? Deciding factors in how we're going to deal with this. How to deal with things like schema updates, how are we going to deal with things like potential for downtime, and how are we going to deal with potentially rolling back or rolling forward from our changes. So the first one, in-place deployments, again, really, really straightforward. We're going to just be replacing whatever application code it is that exists on our existing infrastructure right there. So whether this is deploying an RPM or doing raw code shipping, these are the methods that you could use here. So we're running a command, we're using a tool, it's reaching out, and it's replacing the code. And this is similar to what code deploy would do, what OpsWorks would do, what Elastic Beanstalk would do in terms of just throwing the code out there on the server and replacing what's existing currently right there. You might potentially have to worry about a cutover period, right? If you're using a language that is bundled into a binary like Java, and you have to deal with Tomcat or something restarting, right? What potential for downtime do you have? Maybe you want to pull out instances and put them back into deployment, or back into getting traffic, which kind of leads us more into the next deployment method, which is rolling deployments. So in a rolling deployment, what we're doing is we are going to take out part of the infrastructure at a time. We're going to move traffic from some number of our instances, and then we're going to slowly go and deploy our application code to them such that we're only putting traffic onto the infrastructure that is in a process where it's up and running and healthy. And so we can actually have both versions side by side very, very briefly. And then at some point, we have our new code across all of our instances, and we put back traffic on them. So this is a good way to do things where you don't want to replace the instances that are running like you might do in a red-black deploy where you're actually doing it in an AMI base. And another awesome thing about rolling deployments is it's built into CloudFormation, Beanstalk, and Code Deploy. So in CloudFormation, this is actually really easy to do. This is an example of a auto-scaling group inside of CloudFormation. And what we added a number of months ago and recently added some more functionality to 2 weeks ago or last week is a concept of an update policy. So with an update policy in an auto-scaling group, you could specify a number of instances that you want CloudFormation to allow you to replace at a given time, while specifying a certain number that you're going to require to be a minimum in service. And then you can also set a pause time between them. So if there's some amount of time for the new code to come into effect, this would help you out with that. It's pretty straightforward. Elastic Beanstalk actually kind of builds on this. 2 different methods for it. In application deployments, you can do it in a batched mode, or if you're actually changing the instances under the hood, configuration updates work just the same as auto-scaling update policies. Essentially, Beanstalk is wrapping around CloudFormation in this case to make that happen. This week, we were happy to announce Code Deploy. So Code Deploy makes this actually really, really simple to do rolling deployments through your infrastructure. This is an example here where you can select how it is that you want Code Deploy to push out your code. You can do it 1 instance at a time. You can do it half at a time. Below this, what you don't see is do all of them at a time. You can also customize this. So you can decide what percentage or what number of instances do you want to have left behind while you're deploying the code. You can go today and play with Code Deploy. There's a demo application that you could fire up. This is an example of it. And in the demo application, I have decided that I will do deployment across my instances 50% at a time. Now, I only have 3 instances, so it actually rounds it down. So what it's going to do here is deploy the code to one of the instances, and then the next one, and then the last one finally. And as long as everything goes well, my code has been deployed. So the last option that we have here is red, black, green, blue, whatever kind of colors you want to call it, deploys. Essentially what we're doing here is we're actually standing up parallelized infrastructure, right? In this case, a separate ELB, separate auto-scaling pools, using Route 53's weighted DNS to shift traffic between these. And essentially, if things work well, we're going to continue to increase the traffic onto our red side as we decrease it to our black side. We're going to allow auto-scaling to scale up the instances that we need horizontally as they take more traffic and load, while scaling down those stuff that's in the black pool here because it's taking less traffic and less load. At some point, the black version of our code is receiving no traffic, so we can terminate those auto-scaling groups, terminate that ELB, and then essentially live entirely on the new version of our code. Number of moving pieces here, a little bit more complicated to do this. There are some tools that exist out there to do this. Netflix has a great tool that helps with it, and it is a pattern that we do see people do, and if you use the AMI deployment method, this is pretty much the pattern that you end up going with. So some words of caution when you're going through all of this. A big one that I hear all the time when people talk about moving fast and continuous integration and continuous deployment is schema changes, schema updates. Essentially what you need to do is completely remove schema updates from part of your deployment lifecycle. I think we got more into this with Ruby on Rails and Ruby migrations being a very common thing that people did as part of code deployments because it's basically built into it. However, at scale, it just does not work. You cannot do this in a fast-moving environment. You cannot do it in an environment where you're making many changes rapidly. At a previous job where I worked, we set a set day of the week when schema changes would be allowed. They were reviewed by the operations person who executed upon them, and then they were executed. You had 1 day a week when you can make schema changes, and any code that you might deploy in the next 7 days would have to be dependent on that day the schema changes being made. And again, why is that? Well, schema changes are risk, right? There's a lot of risk potentially involved in doing schema changes unless you're on top of it. And again, this is for relational databases largely. You have to worry about how difficult it is to potentially undo schema changes, right? It's very difficult to roll back a schema change. And it can take a long time on traditional SQL-based databases where you have to worry about things like replication and so forth. So again, unlink this from a deploy, right? Make it part of something that is independent from code deployment. Use things like feature flags inside of your code to be able to turn off or on new features or capabilities that are accessing different parts of your new database schema. Another option is don't ever make destructive changes inside of a database, right? So don't delete columns, don't alter types of columns that you might have inside of a database, pretty much ever, unless you could be 100% sure that you've removed any functional code that could potentially be talking to that part of the database. If you do need to make an alter that is changing something, opt for the method where you create a completely new column defined as that new type, and then copy data from one column into the next, and then flip the code over to talk to that new column. And then eventually you can delete the first. Right? Moving pieces there, but still you want to obviously be extremely careful with your data while enabling you to move fast in this process. And again, be prepared for things to go wrong. It would be foolish of us to talk about this moving fast and doing crazy things without also thinking about, well, what do I do if things break? It's extremely easy these days to set up what people have typically referred to as fail-well websites. Right? For some reason, your site has gone down. You don't want to just be serving up a white page or a timeout. So what you can do very, very easily today with Route 53, ELB, and S3 is set up an S3 bucket as a website host, put some sort of static page in there, or a whole bunch of static pages, and then set up health checks in ELB via Route 53. So Route 53 will be using the ELB health check in this case, and if our ELB has failed its backends, Route 53 is actually going to direct traffic automatically to S3. This is an example of this being set up here in a CloudFormation template. A little difficult to see it in the back here, but what I essentially just have is two record sets, or two records actually, one for my ELB, one for my S3 bucket, saying that I want to do the health check on the ELB, establishing a primary and a secondary option for this individual record, and essentially Route 53 takes care of the rest. So I've actually made a full CloudFormation template sample available to you guys. You can go and download this. It's a gist on GitHub. Essentially what it does is it takes an ELB name, it takes an S3 bucket, takes maybe 3 or 4 other parameters about your infrastructure, and it sets it up for you, makes your life real, real easy. Again, use it as an example. Please do review, read through it, and understand what it's going to be doing for you. But again, this is not something that's super complicated. And you'll see, I think the full template is like 50 lines of JSON. And I'm the kind of person that puts brackets on individual lines, so it's probably a lot less than that. And then as part of this here, again, our deployment method, whatever we choose, again, metrics monitoring, log analysis, right? What's happening? What have we changed? How are things reacting to it? Host level metrics. Did we just deploy out a new AMI and all of a sudden CPU usage is way higher? Do we deploy out new code and all of a sudden we're hitting the disk harder or the application is slower? Service level metrics, right? Things like latency off of an ELB. We deployed new code. Is our site really slow? One of the best ways to tell that is off of latency from something like a load balancer. Log analysis, right? Having dashboards and tools that can look at logs and make them available to you, also a really important thing. And then lastly, external site metrics. Another important thing that people I don't think pay enough attention to. If you're just looking at your infrastructure from the inside, you're not at all seeing what it is that your end users are seeing. So pay attention to those external metrics. When things do break, you obviously have to think a little bit about whether you're going to roll back or roll forward and what that process might look like for you. Are you going to roll back to a previous app version, or do you have the ability to quickly figure out what broke, fix it in your code, get it through CI, get it through whatever environments it needs to, and push it out to production? And depending on which deployment pattern and method you go with, it's going to really affect how you decide which one of these you want to use. So it's a lot harder to roll back raw code shipping if you've replaced in place the files that exist. But it's a lot easier if you do package bundling. Code Deploy, which we just announced this week, has the ability to detect that your instances are failing and pause or stop a code deploy if too many of them have failed as part of a rolling deploy. So that's pretty cool. You can also see visually if your instances are failing and pause and stop the code deploy while it's happening. And then if those instances have failed out, they'd fail out of your ELB, and then you'd only be getting traffic to those healthy instances. So that's a good thing. And then lastly, if you are going to do something like red-black deployments, it's actually, hopefully, very easy for you to be able to just redirect that DNS traffic back to the other side. right? If you still have those parallel stacks running at the same time, and you're able to monitor and see that you've got things going wrong on the red one, well, stop sending traffic to it and just send it to the black side. One of the things we're missing here, a really, really important thing that, again, I don't think a lot of people spend enough time thinking about is communication tools, right? How are we communicating inside of our organization and our team that change is happening? And obviously, I really feel that open communication is one of the key things that allows you to foster moving really fast. And I don't feel that email is the proper communication tool for this. I'm talking about chat, whether it be IRC, Slack, HipChat, Yammer, some other thing like that, something where the people inside your organization that are actively working can reach out to one another really, really quickly and easily and frictionlessly. Make sure, or at least I like to encourage tools that show a chat history or that allow you to store that chat history somewhere. It can be very valuable in understanding if you've got teams that are large and distributed, someone's doing work when someone else is asleep, they wake up the next day and say, hey, what happened? And again, also share that knowledge, right? As part of this is the idea that you are sharing knowledge inside of the organization. Another one of the kind of key principles behind DevOps is the idea that you're tearing down these walls and these barriers between these independent teams that used to keep their knowledge isolated and siloed, making it available across team and organization inside of the business. So, encouraging that every change, whether it be from a developer to someone on the ops team, is putting that change request into a ticket or a ticketing system or issue tracking system. Things like internal mailing lists being searchable and being archived. This is a really important thing. Someone new comes into your team, someone's referencing an email from the previous week that this person obviously would not have seen. Make it so they can go back and see these internal lists as something that's searchable. And then also encourage things like internal wikis and blogs. At Amazon, we actually have a really great internal wiki and blog system. Internal developers, project leads share wonderful information with each other, and it helps us all learn off of the greater organization. So we've seen kind of a combination of these developer tools and these best practices and patterns that we have. What do we have to do here to essentially, again, put all these together across these different environments, right? We want to obviously make this frictionless, easy, simple to do, so some level of automation. So if we think about what our automation workflow might look like, code gets committed by our developer. We want to get tested. We want some sort of code delivery method to be acted upon via some pattern that we've chosen. Potentially more testing, again, if we're pushing to QA or staging or what have you. And then we would want our code eventually deployed to some next environment, right? Whether it is part of a continuous deployment workflow, where it just happens, or whether there's human interaction that needs to happen to move that code to that next place. Some potential bit of rinse and repeat as you go through the environments or through the different stages of testing that you might need to do, and then eventually getting that out there to end user consumption. But essentially, again, right, we don't want to be doing this by hand. We'd like to have some sort of automated robots here helping us move this thing through the process and buzzing along. The good news here at AWS is we've got lots of fun robots to help you out with this. There's a couple that we announced today, right? S3 event notifications, Lambda event-driven actions that you can take. There's tools like Simple Workflow that you can use to put together very complicated workflows. There's pipelines or code pipelines that we briefly announced earlier yesterday. Didn't go into it in this talk because I want something you guys can actually act upon after today. We have our other configuration, or our management and configuration services, CloudFormation, Elastic Beanstalk, OpsWorks Code Deploy, and then now the new container service as well. So let's put these robots together here and see a pattern of what it is that's going to happen in an example scenario. So our developer has committed code to our repository, GitHub, local Git, at some point, the code repository service that we'll be releasing next year. Some concept of a post-commit hook is going to kick off passing that code into a continuous integration environment. Again, you saw the example of how I integrated Travis CI with GitHub. It was dead simple. If I am a horrible coder, which I am, that's going to bounce back to me and say that things have broken. This happens much more often than this next step, which is lights green and things move forward into acting through my code bundler in this case. So let's say that I'm going to generate maybe an RPM or a tarball or something of this code. I like that atomicness, but I don't want to go all the way up to AMI building. What's cool now is after our bundler acts, it can put code or put our deploy asset into an S3 bucket. Now, making use of S3 events, we could go and trigger a Lambda function, right? A little bit of code that's running, just sitting there. It's not an instance I have to maintain or watch. It's something that's just sitting there waiting to be called. And so an S3 event notification could trigger a Lambda function. Lambda function is code that I want to run. Well, what I could do with this is use one of the other AWS SDKs or APIs inside of a Lambda function. In this case, let's say call an app deployment inside of OpsWorks. So Lambda is going to tell OpsWorks, deploy this package. It lives in S3. Here it is. Go do it. OpsWorks then is going to actually handle the deploy, right? It could go and do an in-place replacement of the code that I have running with the new version. And then essentially, I could notify the rest of my team via internal tool or a dashboard that, hey, this deployment has happened and it's live. Maybe I have a chat bot that's going to say, Chris has deployed version blah, blah, blah to yada, yada environment, and away we go. And hopefully, if I'm a good developer that's paying attention, I'm looking at my metrics, looking at my charts and graphs and logs and stuff to understand what I've changed. We can simplify our prod deployment beyond this very easily. Here, in this case, not going to walk through the process step by step. Our developer could go to our internal deployment interface that we have, right? It's gone through staging and QA, let's say, through some sort of other automated functions. The deployment interface could literally just be another web page in front of the OpsWorks APIs. And it could say, OK, when I click this button, tell OpsWorks to deploy this version of the code, suck it out of S3, and put it on our servers. So again, I'm not logging into servers. I'm not making manual changes. I'm never potentially touching a command line. And I'm doing very little to move things through the previous process that we saw here. And essentially what we get to is the idea that automation is good. So when we look again back at that deployment automation, I was using a number of different steps that were just kicked off for me without me having to act on that myself. So again, we come back to what fills the gap here between our developers and our end users. It's this combination of development tools or developer tools, best practices, and patterns. Again, we kind of covered a whole broad range of things today. It's a very big topic. It's going to be very individualized to your team, to your company, to what software you're writing and that you're dealing with. Hopefully you all got something useful out of the session. I want to thank you all for coming to it. I'm going to be in the hallway after this taking questions. We do unfortunately have to clear the room pretty quickly for the next session. Thank you all for coming again. Thank you for coming to reInvent.